Hey guys, it's Roya, and in this video I'll be giving you a practice problem that deals with friction. So here we have Alex, and he's pushing his shopping cart full of bowling balls. And suddenly he sees a thief running through the store, stealing the latest video game console. Now Alex knows that the thief is 2 seconds away from their point of intersection, and that Alex is 8 meters away from it. And I know these are different units, but that's something you'll have to work with. His shopping cart full of bowling balls is 50 kilograms in mass, and he is moving at an initial velocity of 1 meter per second. Now, the coefficient of kinetic friction of the floor is 0.05, and this doesn't have units. What I want you to do is use this information and find the applied force with which Alex needs to push his shopping cart in order for it to crash into the thief at their point of intersection. So I hope you've paused the video and tried that on your own, and now here's how I would do it. We know that the displacement, change in x, equals 1/2 at squared plus initial velocity times time plus initial position. Now, if we were to take this information and plug in numbers, we'd see that the displacement is 8 meters. We'd have 1/2 a, and we don't know a, but we know the time, which is 2 seconds, 2 seconds squared, plus initial velocity, which is 1, times time, which is 2 seconds, plus 0. So if we were to simplify this out, we'd get 8 equals 2a plus 2, and then a equals 3 meters per second squared. Now remember that F equals ma, which equals 3, which is the acceleration, times 50, which is the mass. And this equals 150. I probably should have switched the order of these. But anyway, so we need 150 newtons of total net force to push this cart with an acceleration of 3 meters per second. However, as you can see, there's friction, so the applied force does not equal the net force. And this is why. If we were to look at a force diagram, we'd see that there is mg, there's normal force, and that these are equal. We'd see that there is an applied force, F of A, and a small frictional force, F sub F. Now, we can see from this that the net force equals, in the x direction that is, equals applied force minus frictional force. And that equals 150, because we need enough force to make that acceleration. So, if we look at what F of F equals, remember that F of friction equals mu k times n, and that equals 0.05 times the normal force. And since the normal force is equal to mg, we can just plug in mg, so 50 times 9.8. And that all equals 24.5 newtons. So, if 150 newtons equals F of applied minus F of F, then we get 150 equals F of applied minus 24.5 newtons. And therefore, we get our final answer of F applied equals 174.5 newtons.